Hello everyone. Thanks for joining us today. My name is Danica. I am with 3C Rent, County of San Luis Obispo, and today we have our experts Jennifer Rennick and Grant Murphy from Inbound Green Consulting for our 2025 Energy Code in Practice series, focusing today on single-family additions and alterations. Next slide, please. So before I pass things off to them, I just have a few logistical slides to go over. So just a few quick Zoom reminders before we get started. Please make sure you're on mute throughout the duration of the training, and we highly encourage questions. And if any of them do come up, feel free to put them in the chat, or you can raise your hand and we can unmute you. And also, this session is being recorded and it will be shared with you along with the slides in the next few days. And I'll also put that in the chat for those who are joining in a little late. Next slide, please. So just a little bit about who we are. If you are new to 3C REN, we are the Tri-County Regional Energy Network, and we're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. 3C REN is funded by ratepayer dollars collected through the public goods charge found in our utility bills. And the benefit of being ratepayer funded is that there's no cost to those we serve, and we're able to bring those dollars back into our region. And we currently offer 6 programs focused on 3 services. We have our incentives, we have trainings, and we have technical assistance. Our training today is part of the Energy Code Connect program, and you can find additional trainings and learn more about our other services by visiting our website at 3c-ren.org. And with that, I'll pass things off to Jennifer and Grant to get us started. Thank you.
Thanks, Danica, and welcome everybody. Like Danica said, today is the second in our Energy Code in Practice for the 2025 Energy Code cycle. Grant and I are both certified energy analysts. I'm also a licensed architect, and Grant's also certified passive house and building commissioning professional. So with that, we are going to get started. And FYI, there are learning objectives here for you so that you can get your AIA units if you need them, the ICC units, and also CEA units. Today, we're going to go over an overview kind of quickly for some of the 2025 code highlights. So if you've watched some of the other classes or that we've done or taken it, some of that'll be review, but then we're going to dive in specifically to additions and alterations for the single family residency occupancy. And we're going to touch on some of the envelope features, domestic hot water, how that could impact electric ready if you're adding a second water heater, and some ECC, or what used to be called HERS verifications that are available for credit under the performance method. Grant, before we get started, is there anything you want to add or jump in?
No, just feel free to interrupt, unmute if you'd like. We always like this to be interactive. If not, feel free to shoot stuff into the chat and I can try to answer your questions on the side, or I can interrupt Jennifer and we can discuss it as a topic.
Right. And then today, also, Grant and I will, we go back and forth. I'm mostly going to drive the presentation and do it, and then Grant will definitely stop me or add in things, and especially if there's questions and comments in the chat. And then we can kind of go back and forth with that. So reminder, yes, the 2025 Building Energy Code went into effect January 1st. And one place you could get a hold of all those documents is on the energy.ca.gov CEC's website. And you will be getting a copy of the slides as well. So some of the slides might be a little text heavy. And part of the reason for that was I wanted to give you like code references or some of the language where it seemed like it was useful. And then you would have that as a resource. And I believe Danica will be sending out
the
copy of the slides after the presentation. Okay, so California's been on a pathway to make steady progress towards reducing greenhouse gas emissions and energy efficiency in general, which has saved our state billions of dollars. And so the 2025 standards have been shown to be cost effective, and then they're estimated to save our state $4.8 billion. And so part of the 2025 code was to encourage energy efficient heat pump technology for space heating and water heating. There was expanded PV systems and battery storage standards for the non-single family residential occupancies. There's been improved indoor air quality by strengthening some of our ventilation standards, especially with multifamily. And then there's been this attempt to save water and save energy by reducing the water in our homes, but also reducing water use in non-residential buildings, such as some of the new requirements for chillers and cooling towers. Now, with that said, our energy code and our building code in general is on a 3-year cycle, but the energy code Title 24 Part 6 does engage in a multi-year adoption cycle where the California Energy Commission has to show that these measures being adopted in the energy code are cost effective. So right now, we're under the 2025 year code, and that process started back several years ago to have the code that's now implemented as of January. And we've already begun the code updates and looking at what would be implemented January 1st in 2029. Now, a lot of you might be familiar that we did pass AB 130, and that put a pause on parts of that 2028 code cycle. So specifically the residential standards or the residential occupancies got put a pause on it. So kind of the upshot is now we have the current code in place for 6 years instead of 3 years. So we should be able to get better at the code. We'll have lots of practice and really know it before it changes again. The non-residential standards are expected at this point to continue along the same 3-year cycle. The code standards are available several places. You can get to it through the ICC, through their website. Also, it's in Upcodes, Upcodes is another site, and then through the California Energy Commission directly, and then Energy Code ACE has their reference ACE, and you can have a searchable digital format with Energy Code ACE, which is if you're doing the energy code, if you're one of the folks who are working to be a CEA, you definitely will want to use the Energy Code ACE resource. Now, with that, for those of us who are really into the code, it's really hard to look at the 2025 standards without also including the reference appendices, because those things, that reference appendices is constantly being, the reader of the code is standards is constantly being directed to the reference appendices. So really you need both of them together. So on Energy Code ACE, yes, they both are together, but those reference appendices are not always part. You're not going to find it with the ICC or the Upcodes. And then the other component that's super helpful, especially I found for the additions and alterations for those of you who are working on your CEA or want to be more familiar with the energy code specifically, is the Single Family Residential Alternative Calculation Method Reference Manual, ACM. But that book is the one that really lets you understand what the standard case and base case is if you're going to be doing computer modeling, performance method modeling, which we'll touch on in a moment. But those three things are really helpful. And then there's manuals that go along with it to just help guide a person through how to use the code. And there's also the ACM for the non-res and high-rise, and a new manual for data registry requirements, which is where we upload our performance method or our residential compliance documents for the team to access and for your plans official to access. The energy code itself has an interesting organizational structure, and it's kind of evolved over the years. And really how it's set up is that there's some mandatory measures and there's some occupancy scope definitions and certain energy building regulations that are applicable to all the occupancies. And so those are kind of at the high level and at the top of that building tree. And then there's three buckets that the code has, which is your multifamily residential occupancy types, your single family residential occupancy types, and then everything that's like your not residential occupancy types, except hotel motel is thrown in there. And today we're going to take a look at subchapter 9, which is additions and alterations, but also known as section 150.2. And of course, that subchapter 9 constantly references, the mandatory measures under subchapter 7 and the prescriptive and performance components of subchapter 8, and then it also references back to some of those mandatory measures and definitions that are part of the overall building tree. If you are new to navigating your way around the energy code, then in one of those top level at the beginning of the standards, table 100.0A, there's an application of standards. And this is just a quick excerpt, but these tables are very useful because they'll list the occupancy type based on those kind of major occupancy components we addressed. They'll list the application, what's mandatory measures, where to find it, the prescriptive, the performance, and additions and alterations. Today, of course, we're focusing on the additions and alterations. And sometimes, though, like this refers back to other sections. So, for example, water heating, you're going to find it in the section 110.3, which is part of that big hierarchy, plus section 150.0, which is part of the mandatory measures that are specific to the residential occupancy itself. Now, quick review. I've been throwing out these terms: mandatory, prescriptive, performance. So those three terms are used a lot in the energy code. So as a reminder, if it's a mandatory requirement, it means it's an energy efficiency measure that's applicable to all projects and all project types. And if it's a prescriptive component package, it means that those mandatory requirements are still applicable, but it also means that you're going to follow a checklist or a recipe. And if you follow everything in that checklist for that prescriptive package, then you can prove that your building meets the prescriptive component method or prescriptive component package of the energy code. However, if your project is unable to, or the design isn't what you, the architect, the homeowners want, then you can use what's called the performance method. And so an energy model is set up where it looks at the energy use over a year and that energy budget can be compared to a standard or baseline budget. So you have your standard or baseline budget design, and then the proposed is what you're hoping to make. And if that budget passes, you're good to go, which allows for trade-offs. And a lot of times the things that are in that prescriptive component package is what makes up the baseline for the energy model. And each of those situations is unique to 16 climate zones in California. And our Tri-Counties 3C RAN region includes Santa Barbara, San Luis Obispo, and Ventura counties, and that includes climate zones 4, 5, 6, 9, and 16. So as we go through this, you'll see that a lot of the requirements are based on your climate zone. And then that will determine what set of requirements are applicable.
I just want to chime in on the previous slide, Jennifer.
Yeah.
Often I point out when we do like the new construction projects or the classes on that, I kind of emphasize the performance method and explain why we don't talk much about the prescriptive method. For this class, additions and alterations, a lot of the time the project scope is easier to understand and comply with using the prescriptive method. Maybe it might make a project have to do something that you might not want to do, but the modeling for additions and alterations can be convoluted. And so if you do the prescriptive method, it's going to cheers the registry, and they have a set of different prescriptive forms. Some of them are simple, like they have one for HVAC swap out. That's just a little tab that you say, I'm just doing an HVAC swap out, and they have that set up. So it's pretty TurboTax. A lot of like homeowners even will do it themselves. And I get a lot of coach questions asking to have help walking through it. I can't do it for you, but I can help you kind of walk through those steps.
Yeah, that's really important, right? And so Grant sees a lot more of that prescriptive. And so funny because I was thinking, oh yeah, the performance method, but then I guess the part of the projects I usually get ends up being more robust. And so it's like, oh, we'll just model the whole thing under the performance method. So it really is nuanced on the scope of the work. That's kind of the main takeaway, I would say, for the additions and alterations, is it really depends on the scope of your project. And then, and then we go from there. There's some new metrics, just FYI. There's long-term system costs. And the long-term system costs is akin to like what you would use for economics in looking at long-term system costs, that kind of analysis. But it's long-term system costs in the sense of it's California Energy Commission's projected present net value cost of the California energy systems over a period of 30 years. So it doesn't represent your individual utility bill. So just to be clear on that. And then that's the metric that we'll be dealing with for additions and alterations. But if you've seen some of the other classes or you take the next one's coming up, we'll hit on source energy and peak cooling, which really depends again on what climate zone you're in. And that peak cooling metric just applies to climate zone 4 and 8 through 15. But today, for additions, alterations, it's just the efficiency component of your long-term system costs, which just deals with space conditioning, your water heating, and sometimes the mechanical ventilation will come into play. So here's a little chart just to kind of show you where we were for 2022 and those metrics. And then today, additions, alterations again. So we're just doing the long-term system costs for just the efficiency part of it for additions, alterations, and then that's being phased in, and the TDV is, as a metric, is out. Now, the other kind of unique things with performance method or with additions and alterations, really, like Grant said, a lot of times if the scope is such that it fits under one kind of component that you're dealing with, it's much easier to show you comply prescriptively, like use that recipe, the check card, you fill out the forms, kind of you're done for that alteration you're doing. When it comes to additions, a lot of times we'll see folks wanting to use available trade-offs to get the addition they want. So they might have an addition that adds a lot of glass to that space. And so they'll want to use a performance model where they can model that addition plus all the alterations they might be making to the rest of the house. And they can do any combination of just the addition alone. But if that doesn't work, then they can look at the existing plus the alterations and the additions together. We call it the E plus A plus A. And you can also do your existing plus your alteration alone. So the code under the performance method is a bit flexible that way, but it also in some ways adds to the complexity. So if you're an architect and you're hoping the addition alone complies and it doesn't, then it is additional work that your energy consultant goes into to kind of look at the existing situation and what alterations might be done to get the trade-offs and get you where you need to be for your client and for that project. What that
That's
looks
a
like. Oh, yeah, go ahead.
previously called hers an ECC rating. So a lot of the time, if I have a project that I know is some weird existing plus alterations plus additions, my first recommendation is just to call your AECC rater and have them come out and look at the project. You get that verification out of the way early. And a lot of the time, those professionals will give you a lot of great information ahead of even engaging with someone to do your Tile 24 to say, hey, you have an opportunity to do this, beware of this, hey, this is the stuff we should be looking at. And it can be really helpful as you are starting to design this alteration renovation.
Yeah, I agree. In fact, maybe I should have thrown those two slides earlier in the deck, because that's a really good point to make sooner than later. Yeah. Well, and then, keep that, put a pin in what Grant said, because as we go through this, really a lot of what we're talking about, it's like in the back of your mind, it's like, oh yeah, here's an opportunity for potential credit. So really kind of speaking to the designers out there, the architects, and looking at how do you get this remodel and addition project to comply with the energy code and give the client just a better project as well. So when you take a look at the draft Title 24, Part 6 compliance reports, the compliance summary now will look a bit like this, where there's a lot of blank space. So really, it's just that efficiency metric that's coming into play. And if it says you pass, result complies, you're good to go. And you can do that, like I said, as an additional loan. If that's the case, you're done. Otherwise, doesn't pass, that's where we say, okay, your additional loan didn't pass. And then we come back and work with the architect to see what we need to do for the project. And if you go to the next kind of table or next page in that draft report, it kind of expands out the energy use types and compares it to your standard design, proposed design, and the various metrics. But again, for additions, alterations, we're really just looking at a few of the metrics, not all of them. But with that said, the top part of this table is what it shows up in the energy model that you can use as trade-off. So these are known as your regulated loads, which is your space heating and space cooling. Sometimes IAQ ventilation comes into play. In this example, it does not. Your water heating will come into play often, but not always. Depends on the scope of your project. And then the efficiency compliance totals what we're looking at. And then the non-regulated would be also things that aren't applicable in this case, but are there for informational purposes, like getting an idea of how much impact the indoor lighting or the appliances or plug load has on a project. And that's useful if you're trying to understand relative energy use for the whole building. And then really what we're looking at is those energy efficiency compliance. And it's the same numbers on the previous page. It passes, we're good. So zooming in on, space heating, space cooling, water heating. Sorry, did that a little out of order. So zooming in on just that part, our space heating, space cooling, water heating, these are the metrics that we're looking at. Standard design compared to proposed design, and looking at the compliance margin. And in this case, this particular project, we did better for our space heating. So we have a number that's above, a positive number. So it's showing we're above the standard. But on our space cooling, we did a little bit worse than standard, but not so much to drag our project down. And then on the water heating, this project did much better than the baseline. So that's where our compliance margin came into play. And in this case, we were good. In this particular example, we used the E plus A because the owner wanted to trade off exterior continuous insulation on the walls of their new addition because they wanted those walls to match the rest of the house and the way the windows looked for the rest of the house. So we were playing with that. And like Grant pointed out, a lot of times to understand what's going to be available for trade-offs, we'll want to get a HERS rater out there, or otherwise known now as the ECC, or Energy Code Compliance Rater. So that rater still can do all the same thing with the duct leakage testing, blower leakage testing, field verifications that may come up and be necessary. Like if you're doing a new bathroom or redoing the kitchen, you'll need to look at kitchen hood fans, for example. They can assist with some of the forms, but really key here is to document and verify your existing conditions under that performance method. So kind of a big deal now, because a lot of us who've been doing this for a while will continue to say the word HERS, and now we'll be transitioning to saying ECC, or Energy Code Compliance Rater. And previously, everything with the HERS was under Title 20 as opposed to Title 24. And now they've moved that over to Title 24, Title 24 being the overarching title for our building codes. And we get this new name, and along with it, there's a new quality assurance review auditing process for the ECC rater. And now the ECC rater can even achieve exemplary status. Okay, I think that was a bunch of vocabulary and kind of review of terms, new metrics, but those are the big things that are now new to 2025 energy code. Okay, now we're really going to get into the additions and alterations. And Grant, chime in, jump in as needed. And if there's questions, yeah, feel free to ask them. Oh, great. And Danica put a link to that Energy Code ACE content part for the table 100. That's great. That's so useful. Really useful. Now, under additions and alterations called section 150.2, and there are mandatory measures sections that apply to the existing additions and alterations, but not all of them. And just by definition, additions have some minor updates and new sections for heat pump space heating. Alterations have some minor updates. But, you know, the main takeaway is most of the 2025 changes are relatively similar to what we had under previous code cycles, which is good news for some folks. And for those of you just learning the code, it doesn't really matter so much. You still have the ability to just dive in. In the code for additions and alterations, kind of high level in that section for 150.2, it right away references that your additions have to comply with a number of the mandatory measures. So it's going to reference you back to section 150. And explicitly, it calls out the mandatory measures A through N. So I printed them here on the left in blue, just so you can look at that and, you know, kind of reference. It's hard to go, I think, in the code back and forth, back and forth, back and forth. So this is, to me, it's like a little cheat sheet where you can see that, okay, when it says you also have to comply with the mandatory measures, they're talking about roof insulation and wall insulation, slab on grade insulation, if you're doing a new slab, for example, pipe and tank insulation for your water heating systems, certain things for lighting, and air duct distribution where that's applicable, and the water heating for electric ready when that's applicable. But the things that don't come up would be your solar ready, battery ready, or other electric ready for like your heat pumps, cooktops, and dryers. Those would all be associated just with new construction. And in general, the prescriptive additions follow most of the prescriptive requirements for new construction, except it turns out it's kind of nuanced with the additions, and they're often thrown into these buckets like for 300 square feet or less. That part of C11 for the roofing SRI ratings don't apply under the prescriptive, but keep following along with prescriptive unless you have 1,000 square feet or less, then and you don't have to have a whole house fan in the climate zones where that's applicable, like climate zone 9, for example. And so the way the code is written, how it jumps you back and forth between these mandatory measures, prescriptive measures, lots of exceptions or exemptions or clarifications for these things. It can be a bit complicated. And if you're really trying to like learn the code, this is the one time I do recommend using the ACM manual, kind of the one that tells you what is the baseline and standard, because it also kind of puts it into tables with these buckets. of sizes so that you can quickly see what's your project going to be compared to. So I think that's useful. Anything you want to clarify or anything?
We had a quick question we could just answer on the side.
Okay.
Tally was asking if the square footage is to the exterior of envelope or interior of envelope. This is something that comes up all the time, not in the most consistent way. Energy code wants us to take square footage to the exterior of wall. Um, this often comes up on depending on the jurisdiction, a comment when a modeler does their takeoffs and an architect maybe uses a different square footage, wanting those to match. Sometimes it's not that big of a deal. We're talking small differences. But by energy code, we're supposed to be doing our square footages to the exterior wall.
Yeah, good point. Yes. And some of the other things that come up is just clarifying when your heating or cooling system will be extended to an addition. The existing heating and cooling equipment doesn't need to comply with the Part 6 energy code. It's already there. So there's some clarifications that are unique to additions. And for example, the heating system capacity still must be adequate to meet the minimum requirements for your house, that addition, and that's typically shown through ACA calcs, or if you have a mechanical engineer, they might do ASHRAE calculations. So that's that can come up sometimes. And then there's a bunch of kind of nuanced conditions where if you're extending your duct system from your existing to serve the addition, then there are certain situations where duct leakage testing is going to be triggered. And so each kind of section in the code, it's more about reading all the exceptions and then the certain specific nuanced differences. And then except for that, it mostly follows the prescriptive for new construction. Okay, to me, that's so funny because it's like mostly follows, except for this, and except for that, except for this. And that's why the additions and alterations is nuanced. New to the code, just in general, is the space heating systems. The baseline standard design and the prescriptive is a heat pump. It can be ducted, it can be ductless, but it's going to be a heat pump as opposed to a gas furnace. And also kind of new section to 2025 code is language referencing the defrost and supplementary heating and those control systems on the heat pumps. There's also a bunch of new tables for the additions, alterations, kind of specifically that talks about the maximum capacity, so the size of your heat pump system and sort of what is assumed if it's not field verified, meaning with the ECC rater, or field verified with the ECC rater. And there's some new tables for infiltration rates that really, it's good to see that because this is what's being assumed for a performance model, and or rather for when you're using you're doing your capacity sizing calculations. So this is more of a FYI for the folks who are studying the energy code comes into play. And if you're doing the engineering or sizing the systems, this comes into play. For the architects, it's sort of informational purposes, just to know that these things are part of the code now. For the additions and alterations, IAQ, indoor air quality ventilation, that's the ventilation that is mechanically introduced to the building to bring in fresh outside air. And normally that's part of those prescriptive measures and also part of the performance modeling and mandatory. But if you have an addition of 1,000 square feet or less, the IAQ doesn't apply. And that's why in that project I showed you the performance results, the IAQ ventilation was just 0 across everything because that addition was less than 1,000 square feet. And if you have a junior accessory dwelling unit or JADU, so in other words, it's essentially an alteration, kind of, we call it a remodel because JADUs are interior to main residence, then the IAQ ventilation isn't triggered. But you still have to comply with the mandatory exhaust requirements for your new bathroom and new kitchen, for example. And then those ventilation requirements still continues to be based on ASHRAE 62.2. And if you do have a project that triggers the outside air ventilation requirements, then they will be field verified by your ECC rater. And for your bathrooms and kitchens, for the required exhaust ventilation, those methods for how you meet those requirements, the language has been updated. And then there's some new language specifically around balanced ventilation with heat recovery. And that is a system where you're bringing fresh outside air into a project or into your house, and it goes through a small ERV or HRV core, a small heat exchanger, and it's like a fabric material, looks like a giant, thick, three-dimensional air filter, but that way the energy or heat can be transferred into the outgoing stream, and that way the fresh air that's brought into the building can be tempered. So if it's really hot outside, it'll cool it slightly before introducing it into the house. And if it's really cold outside, it'll warm it up before it introduces it into the house. And here's an example of what that can look like, installed in a closet in a hallway on the right-hand side. And then there was one that I took a picture of at one of the trade shows where they just opened the top of it off on one of the Panasonic units and were showing us where the MERV 13 filter is and the core is behind it. So these systems, it's part of the mandatory measures, but again, if your addition has to be large enough to trigger it, but if it does trigger it and you do use a balanced or supply only system, then there's some requirements that kick in about the air filters being accessible. And also if you have fault indicator display for diagnostics, like it tells you, hey, the filter needs to be changed, the filter needs to be cleaned, then you would want that if you're going to install these units in an attic. And there's also some language that says, hey, your outdoor intakes should be weatherproofed and be located where you can do maintenance on them. And still, just to clarify, because this comes up all the time, because folks are concerned about wildfires and also poor outdoor air quality in certain locations. So yes, all these systems must have an ability for the occupant to turn them off, and it should be labeled, and that that the systems would stay on unless the outdoor air quality is very poor, and then you can turn them off. Kitchen range hood comes up a lot, especially on the additions, alterations that include redoing kitchens. And if you're gutting that kitchen and putting in all new kitchen everything, then yes, your kitchen hood needs to meet the mandatory requirements for ventilation. And then that will depend on whether or not you're installing electric range or duction or a natural gas or propane range. And then the quantity of ventilation exhaust is determined by that. And then your ECC field verification will come out and take a look at it and determine if you meet the requirements like HVI rated, the zones, etc. You can also have field tested if needed with specialized equipment. So it just depends on the strategy and if you bought a hood that's already got all the testing done, and then you're good. And it also depends on how you are venting that system to the outside, and it could trigger a few things here on meeting your ventilation rate. If you have a duct length that's more than 25 feet, for example. Okay, now for the alterations. So that kind of gives you a big idea of the additions. And then for the alterations, there is also a prescriptive component. And again, I listed sort of those prescriptive alterations, A, B, C, D. Now it's by these capital letters. When you go to 150.2 B, section 1, there's not a consistency in how these sections are labeled or numbered. So I found that when I was learning the code, it helped so much to make my own sort of cheat sheets and like quote unquote table of contents on each of these sections, so I could better understand where things were and how to find them. And so I kind of applied that to these slides for you to have handy. And we're going to kind of go through a few of these systems that I think are maybe applicable to what the architects would need to keep track of. And the folks that are doing plans examining, or if you're studying for a CEA, then just everything is applicable. So for the understanding your project for alterations for your ventilation system. So if the IAQ system is being triggered, we're looking at that when we see a project that has entirely new or complete replacement of the ventilation system. And complete replacement means like 75% of your ducts and the associated materials are replaced. And then in that case, then the mandatory measures for IAQ ventilation systems kick in. And when we talk about these balanced IAQ ventilation systems with either heat recovery or ventilation recovery, often what we're talking about is having a small ducted system run throughout the house. There's also through the wall ventilation type systems, but typically we're talking about a ducted system. And so depending on how large of a project you're working on, it could be that you have the main ERV, HRV core in one location, like a closet. And then from there, it would duct out to a manifold. And then from there, a bunch of 3-inch ducts running into various rooms, bringing in fresh air, and then also pulling the quote unquote stale air out at other points.
I have a quick question, Jennifer, that I think it's solid time. Rochelle asks, if you're renovating a bathroom, call it a partial remodel, just renovating the shower stall, can you keep the existing bathroom fan that is switch controlled on the wall, not continuous or automatic. So I would say you're not touching it. There's nothing that requires that you upgrade that ventilation requirement for the scope that you talked about. However, one of the number one things we see in older homes being renovated, doing these a small bathroom remodel, is that the indoor air, the IAQ requirements just aren't met due to the home being built prior code cycles. It's just a common thing that's not happening. So looking at the home's little outdoor air ventilation calc and kind of saying, hey, are we even close to meeting this if we're using the exhaust ventilation route under, you know, it's a pretty easy fix. But I don't think, Jennifer, there's nothing that would trigger in that case because you're just doing changes to the bathroom, not any of the systems. They are existing to remain. So you don't have to, but that's a pretty easy fix that we definitely recommend in that instance.
Yeah, I'll just echo what Grant said. It's true. And it just comes up because folks just end up wanting a better fan, a quieter fan. And so then when you do that, then, you can do it so it meets some of the other code requirements like a
You're not touching,
humidistat.
yeah, if you're not touching the system, the code says it's existing and it can remain. So that's the general rule in these
Yeah,
scoping of alterations.
right. That's right. And again, one of the things that happens with the alteration projects is a lot of times the ducts are altered in an existing home that already has a ducted heating and cooling system. And so there's just triggers for when duct leakage testing by ECC raters required. And so under this code, now if you extend a duct 25 feet, it used to previously be 40, it's triggered. And then the duct leakage testing needs to be tested to 10% leakage or less. And that previously was 15%. And then leakage to the outside, only 7%. And for certain climate zones, the duct insulation has been increased to R8. So that's for climate zones 1, 2, 4, 8 through 10, 12, and 13. So a couple of our climate zones, 4 and 9 in our Tri-Counties regional area would be triggered. And some of the guys I talked to just said, just because they don't want to remember what climate zone they're in, what's going on, if it's triggered or not, they're just installing R8 everywhere. But that would be up to the builder at that point. And just to clarify, when you're working on alterations and you're altering your space heating and cooling system, in other words, replacing it, typically you're not allowed to use ductless electric wall heaters or electric resistance heating, but there is some exceptions. And for example, if you're in a super mild climate zone 7, which is not in our Tri-County region, but for example, if you have a project that is down in that area near you, you could install electric resistance space heating system. If the existing system already is electric resistance in that climate zone 7, then you can, put in the same type. So there's a few exceptions. Otherwise, we're getting away from any kind of electric resistance heating, and we're all moving to heat pumps. And what I've been seeing a lot is that for alterations, remodels going ductless mini splits because they're so easy to install. They're quick. And if you were used to looking at a wall-mounted electric resistance heater anyway, then it's not such a stretch to figure out where to locate a wall-mounted ductless unit. For our envelope features, these kind of fall into these buckets of one of them is the addition 700 square feet or less. Yes, no, and depending on that, depending on which climate zone you're in, basically you're going to have an R38 ceiling insulation or an R30. it's one or the other. The colder climates are 38. In climate zone 3, 5, 6, 7, which is a lot of the Tri-County region, you only have to have an R30, and in all of our Tri-County region, the climate zones, the radiant barriers are required. Otherwise, if your addition is more than 700 square feet, then you're back to following those prescriptive component packages for your insulation in your roof and attic. The one thing that a lot of folks, this was true last code cycle, it's true this code cycle. I see a lot of folks are really surprised when they hear that altered ceilings should be insulated to an R49 or a weighted U factor of 0.02, but that gets triggered in climate zone 4 and climate zone 9, which is part of our Tri-County region. And specifically, it's just been shown that it's cost effective to add more attic ceiling insulation than that R30 or R38 when you're, redoing the whole kind of attic and ceiling. And so then while you're at it for these alterations, that's when you should air seal all the space. And also, if you have existing light fixtures that are not airtight and insulation covered rated, then you need to do something to protect those electrical lights, those recessed lights, and put a cover over them. And then there's some exceptions for it, like if you already have enough insulation in the space for your climate zone, or if you have asbestos in there and you can't, you can't touch it. There's some exceptions, but in general, we're talking an R49 weighted average. And then they specifically, our energy code now references the electric code, and it's the electric code that talks about having, type IC or type insulation covered or insulation contact light fixtures, and then needing a box to go over it. And part of the alterations, prescriptive compliance here is that you do air sealing. So this is a great opportunity in general to really make sure the building is going to perform better. And I put some of the highlights of the language here for your reference. Now, this part used to be a bit more confusing when we talked about additions and alterations and knowing how much insulation we have to put in the walls. This actually got more simplified under the 2025 code. So really what you need to remember is if you're having existing walls in place that you're remodel as part of an addition or alteration, your 2x4 frame walls need to have an R15, which is the equivalent of a high density fiberglass bat, or your 2x6 walls need to be filled with an R21, which again is R21 is typically a high density fiberglass bat. And then you meet the mandatory minimum requirements for your insulation, and you meet the requirements for existing walls that are considered an addition or wall extensions. The new walls, on the other hand, that falls into a different bucket. The new walls, if they're not extensions, then yes, they would need to meet the prescriptive requirements, and that would require sometimes continuous insulation, unless you do a trade-off for the performance method. And so there is a great drawing, and I just added to it a little bit that was in one of the CEC's blueprints, just showing what that wall extension looks like and what a non-wall extended new wall for an addition looks like, and what those requirements could possibly trigger. And so the part we see on our projects a lot of times where people want to go to that performance method, which is where the addition doesn't really have all the walls qualifying as wall extensions. And so prescriptively, they may have been required to do an R5 continuous exterior insulation over their R21 wall, and they don't want to do it. So then we do trade-offs. Same idea for alterations now, which is a change from last time. If you alter a wall, like in your kitchen remodel, then where that wall gets altered, changed, if all the insulation is taken out to like add new windows, for example, then you put R5, 15 in a 2x4 and R21, 2x6. And then if those existing walls already have R11 insulation in them and you're not touching them, you could just leave them. So here's a table from the ACM manual. This one is just formatted in a way that I think is easier to read. The ACM manual, the formatting isn't that great in this new version, but the information is still the same. And this just shows you what you're looking at for the additions and then alterations for all the wall types. And again, all of these in the altered wall wood frame walls is what got increased. And now it just matches the addition. For windows, the new code, U factor is a measure of thermal heat transfer through the window assembly. So small, and it turns out the smaller the number, the better. It's the inverse of an R value that we think of for insulation. So a lot of the climate zones have remained the same, except for a few climate zones now have a U factor of 0.27. So that's decreased. So the windows have gotten a little better. And some climate zones still don't require solar heat gain coefficients. And the solar heat gain coefficient is a measure of how much heat gain you're getting from the sun through the window when the sun is shining on that window. And for the warmer climates, it's typically been a 0.23. And now the change is that for climate zone 15, that just dropped to a 0.20. So fairly straightforward, but that's what you're looking at for your new construction and for your additions. But it gets really nuanced under the alterations section. So I took the information that's, I think, it's kind of disjointed, and I tried to create 3 charts so that you all can have that as a reference and just look up what those requirements would be based on, which climate zone grouping you're in and whether or not you're replacing the windows altogether or adding additional fenestration, or perhaps you're just doing a window replacement that's 75 square feet or less. You'll have slightly different requirements. And the other thing I want to point out is even though these U factors and solar heat gain coefficients might be in some cases much more generous than the prescriptive requirements, they all at least are matching up with the mandatory U factor of 0.40. You're not supposed to go worse than that. And many, many brands are available now with U factor, like the Alpen brand, for example, has a U factor of 0.12. So it doesn't even come close to these numbers. So it's easy to meet, but I put it here for your reference. And so that 0.40 is what you need for that window replacement. That's at 75 square feet. Skylight replacement, 0.40, also meets the mandatory minimum. And then the 0.27 is consistent with the prescriptive measure. Fairly straightforward, and there is an exception that, or exemption, that 16 square feet of new fenestration or skylight doesn't have to meet the total required fenestration and west facing requirement. And those total glazing, it is a percent of the floor area, and the west facing glazing, percent of the floor area, which is a little different. In commercial projects, we talk about window to wall, but in residential, it's based on your floor area. Okay, so then I broke that out into table for climate zones 6 through 10 and 15, and then climate zones 2, 4, 11 through 14, just to make it, I think, easier to look up what you need. And just, climate zone 6 through 15, 0.35 for solar heat gain coefficient. So more generous than you would have prescriptively. But climate zone 15 is a 0.23. So not so generous. It just fits with the old, last year's requirements. And then same with the other warmer climate or not so extreme climate zones. You can have a 0.35. And then for your total additional fenestration or more than 75 square feet replacement, it's a 0.30, 0.23 on the solar heat gain coefficient. So it's consistent with what is required now prescriptively. Where we get into seeing some difficulty is if folks are in the WUI or high fire hazard area. The Energy Code does have an exemption for that mandatory maximum weighted average U factor of 0.4, and meaning you can use a window that has a higher U factor. It won't perform as well, but if it's WUI rated, you're allowed to use it. Although it's, I'm hearing from the other energy consultants out there that you can't really model your project if you're doing a performance model with a U factor that's worse than 0.4. So that's something, just FYI, if that comes up, where something has to be worked out. However, with that said, if your client is really interested in energy performance and they have the budget for it, and they want to meet, and they're required to meet the WUI requirements, there is at least one thermally broken steel frame window residential construction that is approved now, and it's the Riviera Bronze, and you can find that in the State Fire Marshal listed Wildlands Urban Products Handbook, and there's the link there. But that one would meet the Energy Code, the mandatory maximum U factor, and WUI all in one. I haven't priced them out, so I'm curious. I think I heard there might be one other brand that possibly could do it, but I don't think they're in the book yet, and that I'm looking forward to seeing that. Okay, now we could talk about the water heaters. So to me, this is a lot of information because of the additions and alterations. I think it's nuanced. It's depends on your condition, and every situation's a bit unique. So I think it's a little tricky to kind of think about it all together all at once, which is why Grant and I are also code coaches for you folks. So, and you can reach out to Danica through the Code Coach service, and we can help you with your Code Coach questions for free as part of a service to the greater community. For your water heaters, now change from before is prescriptively, if you're just like Grant was saying, if you're complying with these things prescriptively and you're adding a water heater, then it's got to be a heat pump. And you can either have a NEA Tier 3 heat pump, which you can look it up for NEA to find out which brands are, or, there's some other requirements that you would include with a heat pump that isn't NEA Tier 3. And then if your client is adding that second water heater or additional water heater and they really want gas or propane, then you would just automatically have to go to the performance method. Then prescriptive component compliance isn't an option. And then if you have an addition that's 500 square feet or less, you can use an electric water heater with point of use distribution. And then that point of use distribution is defined in the reference appendices. And this is a plan check item, meaning the architects should show the distance from that water heater to their hot water plumbed fixtures, because then from the reference appendices, table RA 4.4.5, it tells you how much length of pipe in plan view you're allowed to have based on the diameter size of your piping. And then just FYI, the showers, you're going to use 1/2 inch, your sinks, 3/8 inch. And this would be shown on the plan. And then your ECC provider rater installation would look to see that water heater was installed. They don't actively check your pipe lengths, but they do look to see that the water heater meets these requirements. And a lot of ways this is going to happen is the water heater has to be manifolded down right away, because a lot of the ports off of almost all the water heaters is 3/4 of an inch. And so then you need to take that 3/4 inch and then right away get it down to 1/2 inch, and then neck some of those right away to the 3/8 inch so that you can meet those line length requirements. So this is just an example of what like a whole system PEX type looks like on the left, and then on the right, it's just a little snapshot of just the cold water part of it. But they also make them out of, potable water, non-plastic parts that also interact with the PEX piping or other piping. You can get it that way. For the integrated water heaters, I put this slide in here because there's things to know. This comes up on remodels a lot. Like, where should we locate it? How much space do we need? What else do I need to have for this? So especially on, new construction too. I mean, it's just new for the heat pump water heaters. And so this is here as a reference to give you kind of a visual and a labeling of what all the parts and pieces are that are needed for heat pump water heaters. And as a designer, you want to have enough room for all of it. So new to the mandatory measures section is it just clarifies that heat pump water heaters need a backup heating source in certain situations, which often just means it's the electric resistance heating element inside your appliance already. This is the most straightforward. Some of them don't have it, but most of them do. And then there's special circumstances you can use to meet that requirement. And that the system, the heat pump itself, needs air. It needs a certain volume of space in order to have that air. And that also dictates the net free area of permanent openings. And it also dictates what net free ventilation area you're going to need on that opening for your ducted system. And that the duct should be sealed and use R6 insulation if you're ducting them to the outdoors. And then there are some mandatory requirements for the piping and your tanks and these pipe insulation. You follow the California Plumbing Code. And then I've given you here some exceptions when it's not required, but this is the code section that's referenced. and it's part of the plumbing code where you find that insulation. Now, a lot of times what we'll see is that the insulation's just missing on the hot water piping. You're supposed to insulate it. So if you notice that, that's not a complete job and they should come back and fix it. Like, I was going to say this one, but it's not true. That exposed copper pipe, it was part of the pressure temperature relief valve. Here's an example of an installation in a garage workshop area. That's a great location because there's plenty of volume. They're easy to install and it's fairly straightforward. And you're kind of done. But not all remodels, not all additions and those projects you're working on are going to have the space, and some of them don't have garages. So if that's the case, then it's possible to build an enclosure. And this one doesn't, this one's in process, so the final roof isn't on it yet. But this one was on a project for one of the builders we work with, Mike Corrigan, who does the BPT programs with us. And, you know, this is an acceptable way to also install it and meet all those requirements and keep things quiet. Now, the one thing, okay, architects, energy consultants, on your Title 24 CF1R, then the one thing, if you do something like this, what you need to make sure is that yes, you probably are using a NEA rated heat pump water heater, but mostly take a look at the table that deals with the heat pump water heater specifically and look at the tank location and the ducted air source or ducted outside air source. It's not always ducted, but if you do an installation like this that is in an exterior closet that meets all the net free ventilation, et cetera, then those all should say outside. And if that's the case, when you do your performance method, then you're complying, and this works in a lot of mild climate zones that we have in the Tri-County region. Now, what's kind of new and what we're seeing in some of our milder climate zones on the coast is a metal cabinet. And we're seeing it more around Santa Barbara and Ventura area than I have seen in San Luis Obispo County. But we have been getting code coach questions on this, and they're wondering, is the outdoor metal cabinet allowed under the 2025 code? Maybe, maybe not. And so what you want to know is that CF1R, does it show that the tank is outside and that the inlet and outlet air is outside? Is the unit actually protected from weather? Can it get all the ventilation it needs in this cabinet? What kind of door does it have? Does it meet those mandatory requirements? And then some of the other things we've seen is that the pressure and temperature relief and condensate lines haven't been discharged properly. And so that might be in violation of certain plumbing and mechanical codes. And then a lot of times we've seen it where the hot water piping isn't insulated. So again, it's possible this would work, but maybe not. So this is an FYI for all of you. For prescriptive alterations, meaning hot water heater replacement, it's really kind of the same sort of straightforward thing. Piping insulation, yes. Your distribution system, if you have a recirc pump that exists, you need to make sure that it's now a demand recirc pump. And then the water heating types, again, you could have natural gas or propane, but otherwise you've got your heat pumps. And if electric resistance water heater was there already, you could still use electric resistance water heater. But at that point, if it were me, I would convert it to a heat pump. It's still electric. And so this hasn't changed under the 2025 code. That's still the same. There was a great building counter card for single family residential water heater alterations. I put it in here for reference. I spoke with some of the folks from the CEC and they told me that this was going to be updated, but the information is virtually the same. So it's still maybe a good, useful tool for you folks in the at plan check and in plans examination. When it comes to electric ready though, this could possibly be triggered if you're adding a second water heater and you want that second water heater to be natural gas and propane. And because of that, you have to use the performance method. And if you're doing all of that, then you still need to make space for a future heat pump water heater. Otherwise, this part of electric ready, it isn't required. So I put this in here for reference. We haven't seen it come up very much, but it might. The other reason I put it in here is because the question comes up all the time, like how much space do I need for a heat pump water heater? And I found that 30 by 30 by 7 feet that you have for the heat pump water heater ready is actually a good rule of thumb to use for the space you need for your heat pump water heater that you're going to install. Grant and I were working on a project and I was looking at that and it's like, okay, I was helping the design team look at this and it's like 28 by 28, is the tightest to meet the clearances for a specific brand of heat pump. And it's like, yeah, you might as well just do the 30 by 30 and have an inch or two of wiggle room, So here's a good diagram of what that looks like. Oh, I just noticed I have a floater image there. I will get rid of that before you get the heat pump water heater. Sorry about that. So that diagram will be cleaned up of what it looks like to pre-wire for it and also pre-wire, and then specifically mentions you need that condensate drain because a heat pump does make condensate. Although that condensate's perfectly clean water, you do have to deal with it, whether you install it or you're just heat pump water heater ready. And that's what, that could look like. You could have these plumbed over to a floor drain. And there's greater alignment with the electric code and the energy code, specifically kind of tying these mandatory measures, electric ready measures back and forth now between the two. So I included this electric code language for your reference, especially if you're doing the plans examination side. Now for ECC verification opportunities credits, they're available. So this comes back to looking at that existing conditions. QII isn't necessarily triggered, but it might be for additions over 700 square feet. Again, it's kind of nuanced to the size of the project, and you could use it as a credit, or if not, it might be a penalty in the performance method. And again, this is all performance method. The only time we're really dealing with these verified existing conditions is under performance. And envelope leakage testing, just FYI, it could be done, but it's not that easy of a credit to take, so we don't see it too much. Of course, kitchen hood, new kitchen, that would be triggered. And then the verified existing conditions allows you to have trade-offs. And there's things, this scope would really be triggered based on what you're doing for your project. So as someone doing the energy modeling, I would only check the boxes of the aspects that I know that the project's going to do or be benefiting from. And a lot of times it's improving the hot water heating, improving the windows, and adding more attic insulation. Those are kind of the top three we see. And then that way we can trade off on more glass by having better glass and trade off some of that exterior wall insulation by having better attic, roof, and hot water heating. And then, of course, not shown on here, but you could do all pipes insulated and have that verified and get a credit for it. And so what that looks like for the QII, air sealing at the base, make sure the insulation is installed properly. For your water heating, we're seeing that a replacement water heater can be a really valuable credit when you have the verified system that's being altered. That, and you do a heat pump water heater, that gives a big bonus. And then having that second water heater isn't really necessarily a credit, but if you know what you're being compared to, again, the ACM manual, then at least you won't get a penalty. And in this case, it's really simple. You're going to get compared to a heat pump water heater, unless it is an addition under 500 square feet. And then all pipes insulated credit, it would look something more like this, where you really do see all the insulation on all that piping. So what we recommend is that you do get that HERS rater out there to take a look at the existing conditions. And that way the design team can make some informed decisions for kind of your best performance and your trade-offs. And if you don't do the existing conditions, then there's a default table, 150.2G. That table name's changed. FYI, it's now G. And if you hire the HERS rater during the design stage, it could help your overall project. Again, depends on the scope and how big your addition and remodeling effort is. And then we highly, highly recommend that once you know what all those special features are going to be, or what the ECC or HERS field verification is going to be, that you put it on the cover sheet and just call it out on your project so that it alerts your builder and everyone else on the team that they're going to need to look out for that. And if you have more questions about the Code Coach, we are here for you as code coaches. And with that, I'm handing it back over to Danica, and then we'll be able to close out. And if there are some lingering questions or comments or anything, I'm happy to stay on the line a little bit longer if that is okay with Danica.
Yes, absolutely. Yeah, I'll make this super quick so that if there are any questions, we can address that at the end. But I did launch a survey. Please fill out that survey. Let us know how we can improve. Let us know what topics you're interested in. And if you have any questions with receiving your AIA or ICC units, those should be distributed automatically. However, if you encounter any issues, feel free to reach out to my email. And as a reminder, you will be receiving the slides and the recording in your inbox in the next couple of days. And if you are interested in attending the rest of the series, those registration links are actually now open. So when you get the slides, the links are there, and you can also find it on our website. And we also have an Ask the Experts load on heating and cooling load calculations in 2 days. I believe that's Thursday. So if you are interested in that, feel free to attend. And I'll pass it back to Grant and Jennifer if there are more questions.
If anyone has additional questions, please shoot them in. We had a quick one. Julie's asking about expansion tanks, Jennifer.
Yes.
Typically, I see that they're required, but then it looks like most of your photos didn't have them in the projects. Do you know specifically? It usually has to do with the city water pressure being like
Right.
an
And
open system. Do you know if those
that's right.
projects that you were using?
Yeah, you're right. The projects I grabbed, yeah, those particular ones didn't have an expansion tank. But a lot of times they do. I just happened to, well, one of the projects One of the project images early on did have an expansion tank, but I might have cropped it so you didn't see it. And then the several after that did not. So it depends on the location. Depends on your location.
Yeah, I mean, that's
But
a good
that would,
question. Usually my understanding is just that if the city allows pressure to flow backwards, then you don't need it. And I don't deal with that very often to know like specific sites in our areas where they allow it or not. Um, I'll have to ask one of my inspectors and see how they handle it in our areas. But a lot of my projects, I usually see it's specified by the contractor.
yeah. And then also depends, Julie, on whether you're going to be installing the system with, for example, like if you know what you're going to be installing and you're not doing it for electric ready, but you're doing it to have space, then you can kind of map it out a little bit and look at the actual dimensions of the product. But there's a lot of times what I'll see is the expansion tank is plumbed up above the tank and kind of in the corner. If it's in like an alcove or closet that's big enough, and then it's braced, on the wall. And then that's where I've typically seen it.
Uh,
Yeah.
a bigger closet that we're this is one of the most problematic parts of the code in these units is just how big of a closet and how do I make sure these things work? And I want it as small as possible. By code, no, there's no additional language associated with you have an expansion tank, you don't. That means bigger footprint. It really falls on the installer and making sure that they can accommodate whatever size expansion tank they're including. Typically, like Jennifer said, it fits above and it fits within that space. If you're getting a 30 by 30 by 7, in all likelihood, you can fit it. It becomes very much of how it's being plumbed, where it's being located. Um, if the plumber has the ability to increase that space, I'm sure they would take it.
Yeah. Some of the projects, yeah, I mean, we'll be touching on it more, but I've got some examples of where the plumber was like amazing on how they fit it into the project, but then no one thought through the fact that the door to that tiny closet was not fully louvered, was solid, and it chokes off the ability for the heat pump to function unless it's ducted. But then adding the ducts means you need more space. And in some cases, if the closet's too small, your exhaust air is mashed up against the closet. So the other part of it is those things I'm describing, they weren't in the code. Some of it now is in the mandatory measures energy code, but it all is in the brand specific installation instructions, which tells you, for example, like one of the ones I was looking at was an A&O Smith with ducts at the top. The hot and cold water can be plumbed at the top or on the sides to give your plumber some option there. And then they're, pretty explicit saying, hey, you need 6 inches clear in front for working the panel. And then they put the ducts on top to make it easier, but you need access to the filter. And like the ream I was looking at recently, they're saying you need a minimum. They say it's 0 clearances, but then when you dig in deeper on the installation, they really want you to have 12 to 24 inches, clear on that exhaust air side of it. So again, it kind of depends on how it's located in the closet. Is it ducted? How do you rotate it? And the closets with the duct design that works the best are bigger than 30 by 30. Typically, because the ducts are coming off the side on most of the units. But now A.O. Smith and blanking on the think there's another brand that oh, well, it's a brand that A.O. Smith makes. It's their, they're the mothership, and so the brands they make have ducts coming up off the top, which could be burned.
Jennifer, Jake asked about the electric ready. That would be for new construction. Not that we didn't touch on that those requirements because that's not part of additions alterations. And he referenced 3.5 by 3.5. I believe 2022 was 2.5 by 2.5.
But that's in
Um,
the multifamily. There isn't that same requirement in single family.
so that code section being located, and was it 3.5 by 3.5? No,
Uh, I don't recall, but
maybe
it
it got updated.
is, the space is more, I do recall the space being more generous in multifamily. I'm just off the top of my head, but I could probably find it for you real quick. I just happen to have
Um,
the trigger sheet handy.
yeah, Jake, that was something that under 2022, it was in multifamily, and a lot of people were grabbing it because it made sense for single family, because there was no code specifying it that concretely. And we were having a lot of really bad installs because people just weren't including enough space for these. So it was often referenced. Now I'm just going to point you back to that new mandatory code section that Jennifer rattled off earlier that's in the slides, because that really lays out the required size by code.
Yeah. Okay,
Tally
great.
asks,
Thanks, Grant.
conversion of existing accessory structure to an ADU and alteration or new. So there's a couple different options. I think we have ADUs coming up in another one. Yeah, 4.8. Is that us, Danica? That's the next one in this series, right? That we're going to
Yes,
go into that for
it
sure.
will.
Um, Pretty much it can be called an addition in most cases if it's attached or if it's existing, like a garage conversion. As soon as it's detached and new build, it's going to be considered new construction. So we'll outline that in the next training in more detail.
Yeah, if you're going from, if that accessory structure is unconditioned, like it's a new occupancy or it was some uh, unconditioned part of your house complex, then it would be considered an addition. It kept going from unconditioned to now a conditioned occupancy is considered an addition. And it's also nuanced too, where some of that you'll find it in that ACM manual and how you're to model it. Okay, are we good on questions? And we probably should let folks go.
Yes. Yeah, I don't see any more questions. Thank you so much, everybody. Thank you, Jennifer and Grant. And with that, have a nice rest of your day.
Thanks, everybody.
Hey, everyone.